Is screen visible?
Yes.
Okay, so for what we discussed, we discussed this basic properties of continuous functions, sequential criteria, right? So now we want to extend this idea of continuity and various applications of continuity. So you want to extend this idea of continuity on intervals or some larger sets. So far we discuss continuity of functions locally. So locally means we discuss continuity of functions uh, at a point, and then we discuss everything about the continuity of a function at a point. Now we want to extend this idea to continuity on intervals. So on intervals. Right. So before going to this, we'll see some definitions. So bounded function, right, so which we already discussed. So what is the definition of bounded function? A function f defined on set A to R to be bounded if. So what is the definition of bounded function? So what do you think? What should be definition of bounded function?
There exists an m such that f of x is mod of f of x is less than m.
Right. So function is said to be bounded on set A because domain of function is a if there exists a number m, whatever it may be, such that the absolute value of function is less than or equal to m for each x in this A. So that is minus m less equal fx less equal m. So if geometrically, if our domain is this set A and this is m and this is minus m is positive, so minus m is negative. And if you look at y is equal to m and y is equal to minus m and y is equal to minus m, then what this definition suggests, if for every x in A, so the value of function lies in between minus m and m. So if this is my set A, right, then is it bounded? Does the value of function lies in between minus m and m?
No, sir.
No, sir.
So here it is not, but if you look at the points in A, right, A is only this part, this interval. Then for every x in A, is it true? For
Yes,
every
sir.
x in A, absolute value of f of x is less than or equal to them. It is true. Outside A, we are not worried because we are interested in domain. We are interested in set A. So what happens for points in A? So that means if you choose any x in A and look at f of x, m and minus m, then if you see that the value of function at x, f of x lies in between minus m and m. If you choose any x in A. Outside A, we are not worried, right? So bounded on A. So for example, f of x is equal to sine x, right? And if you look at this, so this we already discussed this, but I am repeating this. since we are going to uh, discuss the continuity of such functions. So, if you look at the absolute value of f of x, that means sin x, which is less than or equal to 1 for all x, right? So, for every x, absolute value of sin less equal. So, in this case, m is 1, right? So, bound m is a bound for this function. So, m is equal to 1 is a bound for f on R. A question I would like to ask is m is equal to 10 bound?
Yes, sir.
Yes, and therefore this bound is not unique. The bounded means we have to produce at least one bound. If you are able to produce at least one bound, that is sufficient, not necessary what is exact bound, right? So if you take f of x is equal to x square in x is in R, is it bounded
No, sir.
on R? The answer is no. Because if you look at the graph of f of x is equal to x square, if you try to put any bound m, then we'll see that there exists x at which value of function f of x is greater than m. Since for any m greater than 0, there exists x, right, in R, such that f of x is equal to x square is greater than m. Whatever number you give m, I can give you x so that f of x is greater than m. So not bounded on R. But then is this function bounded on 0 to 10? Now I am not saying on R, I am saying on the interval 0 to 10,
Yes, sir.
Yes, sir.
right? So 0 to 10, and if you look at the graph of this function on 0 to 10, now I am interested only on this interval. And on this interval, we see that e f of x is less than or equal to 100 for every x in 0 to 10. And this is easy to see, right? And therefore, what is m in this case? 100, that we see easily. Therefore, the same function may be bounded on some set, but may not be bounded on some another set. So it depends on which set you are talking about and which function, right? So that you should understand. So if I define f of x is equal to 1 by x, right? X is in 0 to infinity, right? So is f bounded on 0 to infinity?
No, sir.
No, because if you see the graph of this function on 0 to infinity, if you put any m, I can give you x which is close to 0 so that f of x is greater than m. So given any m, there exists x. For example, suppose somebody says that 2000 is a bound. Is it true? If somebody says that
No,
2000
sir.
is a bound, no. Why it is not true? Because I can take x is equal to 2001, which is in domain, right? X is equal to 2001. Is it in the domain?
Yes, sir.
So, not 2000, what I want. I will take x is equal to 1 upon 2001, which is in the domain. Then, what is f of at this point? What is value of function at this point?
2001.
2001, which is greater than your m is equal to 2000, right? So you give me any m, I can give you x at which value of function is greater than that m. So no bound exists, right? So there exists x. And what is the given any m? What is the choice for x? 1 upon m plus 1, which is in the domain, right? Whatever m is given, I can give you x, which is 1 upon m plus 1, such that f of x is m plus 1 is strictly greater than m. So no number is a bound. Now, the second question I would like to ask is f bounded on 0 to 1. Now I am taking smaller interval. Is it bounded on 0 to 1?
No, sir.
Still no, right? Because if you look at the graph of function on 0 to 1, still problem is near 0, right? Unless you avoid 0, the situation will not change. Problem is near 0. So if you take smaller interval 0 to 1, still problem is there, because by the same reason, given any x, I can choose, given any m, I can choose x, which is very close to 0, at which value of function is greater than m. Now, is f bounded on 1 to infinity?
Yes, sir.
Right. Now I am talking about interval 1 to infinity, not before 1. So certainly it is bounded. If you see the graph of 1 by x, at 1 value is 1. So answer is yes. Because what is f of x? F of x is less than or equal to 1 for every x in 1 to infinity. Why? When I say x greater than or equal to 1, then 1 by x is less than or equal to 1. That means f of x is less than or equal to 1. But already x is positive, so fx is positive. Therefore, we can say that absolute value of f of x is less than or equal to m is. So this function is bounded. So same function on the different interval it was unbounded. On the another interval it is bounded. So that you should understand, right? Now, so a function f on a to r is unbounded if, when we say that function is unbounded, what is the negation of bounded? What is the negation of boundedness?
For all m greater than 0, f of x is less. Mod of f of x
Right.
is less.
So a function is unbounded on state A if there is no m such that f of x is less equal m for every x in the domain. So there is no such m. If you have at least one m which is a bound, then we declare that function is bounded. Otherwise, if there is no such m at all, then we can say function is not bounded. So alternatively, how will you state this? See, logically, the different ways of understanding or looking at the same statement is very essential, right? So that is, there is no such m at all means what? For every choice of m, right? You choose any, you just pick up any m, that m is not a bound. That means there is no such m, right? So for any m, right? For any m is not a bound. For f, that is, any m is not a bound means what? For any m, it is not possible that f of x is less than or equal to m for every x in A, right? Means what? That is, for any m, f of x is less equal m is not possible for all x. Means what? What is the negation?
f of x is greater than m.
See, something is not possible for all x. Suppose I say that every student in FIBSC E division uh, of, is from Mumbai. Is not possible for every student. Every student from B division, E division is from Mumbai is not possible for every student. Means what? What is the negation? What is the negation of the statement that every student from E division is from Mumbai? What is the negation?
There is a
There is
student which is not from Mumbai.
Exactly. So it is not possible for every x in A means what? There exists x, right? In A such that f of x less equal m fails means what? Absolute value of f of x greater than m. That means you give me any m, I can give you x. F of x is greater than m. That is what it means, right? So therefore, this is a negation of. Is it clear? Right? That's what we did. The function 1 by x on interval 0 to 1 is not bounded because if you give me any x m, I gave you x for which f of x is greater than m. So no m is a bound. So logically the thing should be clear, right? We are interested in logically how to understand these statements. Correct? Okay. Now, secondly, uh, what is a Bolzano-Weierstrass theorem? Do you remember the Bolzano-Weierstrass theorem and in what context we state this theorem? Yes, in what context we stated this theorem earlier? Yes, anybody? We already stated this theorem. Is it about real numbers or is it about limit or is it about continuity? What is it is about what?
continuity of f of
So
No,
it is about subsequences.
sequences, right? Every bounded sequence has a convergent subsequence, right?
Yes, sir.
Has a convergent subsequence. So this is a Bolzano-Weierstrass theorem. And what is a bounded sequence? What is a bounded sequence? Sequence xn is bounded if there exists m such that absolute value of xn is less than or equal to m for all n. That means each term is bounded by m, right? You know this. And what is a subsequence of a sequence? What is subsequence of a sequence? Given a sequence, if we delete some terms, from xn, we get subsequence, right? Just delete some terms of the sequence, whatever remaining is a subsequence. That's it. And therefore, ultimately, if you delete third term, then fourth term gets shifted to third place. That means the position changes, right? So, for example, if nk is equal to 2k, then xnk is x2k is a subsequence of xn. That means what are the terms of subsequence? X2, k running from 1 to infinity, x2, x4, x6, x8, right? That means first, third, fifth, seven terms deleted, right? And therefore, x1, x2, x3, x4, x5, x6. This is the original sequence. Now, if you delete first, third, fifth, and so on, this term is deleted. This is deleted. This is what remains x2. And now x4 will occupy second place. x6 will occupy third place. Right. And therefore, what is the k stands for? Position of term in subsequence, and nk stands for position of that term in original sequence. So that we already discussed. So if sequence is bounded, there is a convergent subsequence. So this statement is clear. Bolzano-Weierstrass theorem. Yes.
Yes,
Yes,
sir.
sir.
Yes, sir.
Even the original sequence is not convergent, the subsequence exists which is convergent. For example, minus 1 raised to n. And xn is equal to minus 1 raised to n is divergent, right?
Yes, sir.
Now, if I take nk is equal to 2k, then xnk is equal to x2k. What is this subsequence? Minus 1 raised to 2k. It is a constant sequence 1. Right, so we deleted our odd terms, that means minus 1 terms. And what we get, the subsequence convergent. And why this is possible in this case? Because you look at xn, absolute value of xn, that means minus 1 raised to n, which is 1. We can say less equal 1. Because our xn is bounded, that's why we could find a subsequence which is convergent. Right. Okay, so what we discussed so far, what is the meaning of bounded function and how to uh, when function is not bounded on some set, means for any m, there is no such m. That means for any m, we can produce x. Then what we revise? Bolzano-Weierstrass theorem. What Bolzano-Weierstrass theorem says, every bounded sequence has a convergent subsequence. Okay, now third point I would like to explain what is interval. What is interval? So of real line is a set I such that for any x and y in I, the segment xy, segment joining x to y is all those t such that is contained in I. So what is the definition of interval? Which set is called as an interval? That means you choose any 2 points in that set, right? For example, if I take I is equal to x such that 0 less than x less than 1, is it an interval?
Yes, sir.
So what my definition of interval says ki some set. This is a subset of R. And why I'm saying that it is interval, because if you choose any two points x and y in that set and join them by a line segment, that entire line segment contained inside that set, then that set is interval, right? Now, if I look at another example, a is equal to those real numbers for which 0 less than x less than 1, or uh, 2 less than x less than 3, right? So what it says, is it interval?
No, sir.
So what my definition of this is, says ki all x lies in between 0 and 1, or all those x lies in between 2 and 3. And therefore, what is my set here is set of points from 0 to 1 and 2 to 3. So the part in between 2 and 3, 1 and 2 is not included in my set. So this is not interval. So basically this is, or means what? Those x for which 0 less than x less than 1 union those x for which 2 less than x less than 3. Right? That means it is 0 to 1 union 2 to 3. So this is not interval. This is union of intervals that you can say. So because not an interval. Why? Because the definition of interval fails. And what fails? Suppose because if we choose x is equal to half and y is equal to 5 by 2, are these in the set A? X and y are members of set A? Yes. X is equal to half and y is equal to 5 by 2. Are they members of the set A?
Yes, sir.
Yes. If you choose these 2 points, then the line segment x to y. What is the line segment joining x to y? Is half to 5 by 2, right? So all those t which lies in between x and y. That means all those t which lies in between half and 5 by 2. Is this contained in A?
No, sir.
No, sir.
Right. So if I join half and 5 by 2, then that line segment is not entirely inside A. Therefore, this set is not an interval. Do you agree? What I am saying, is it clear?
Yes, sir.
Fine. So this is not an interval. So the definition of interval is clear. Some set is interval if you choose any 2 points in that set and join them by a line segment. That entire line segment should lie inside that set. That is a simple definition. So uh, intervals A to B, A to B, right? So or A to B, A to B. So okay, what is the difference between first interval and second interval? What is the difference?
In the first interval, A and B are not included.
Very good. So endpoints are not included in second and third. In second, A is included, but in third, A is not included, and so on. So that difference you can understand, right? So interval I is equal to A, B. So what is this interval? Those real numbers for which A less than X less than B. So those X which are strictly greater than is strictly less than. So I can write this as all those real numbers for which X greater than A intersection with those real set of real numbers for which X less than B. Right? Is it same as A to infinity intersection with minus infinity to B? Is it true?
Yes, sir.
Right. So A to infinity and minus infinity to B. What is the common that you can understand? So A, B. So A to infinity this part and minus infinity to B this part, and this is common part, which is our interval A to B. That is another way to look at this. Is called as an open interval. So why open? Because it is open at two ends. And what does it mean geometrically? It is open at two ends means what? Because B, it is open at B means what? E, B is not included. That means what basically happens? It is open. What is happening due to open? For example, if I take I is equal to 0 to 1, is it open interval?
Yes, sir.
And what is the significance of saying that it is open? Because there exists if I take a sequence xn is 1 by n is the sequence, then is this sequence is in I for all n? Is it true? Do you understand?
So, but one is also included.
Okay, forget about 1. Let us take n plus 1. Right. Xn is equal to 1 upon n plus 1. Is it in I for all n?
Yes, sir.
Right. That means if you look at this sequence of 1 by 3 and so on. So every term is in I. But if you keep on moving along this sequence, right? If you keep on walking along this sequence, first step is half, my second step is 1 by 3, third step is 1 by 4. Keep on doing this. Ultimately, at the end, where you will reach? Where you will reach? What will be the destiny? Yes,
0.
0, which is not in I, right? The destiny is outside. That is the problem. So due to open, that means if your room is open, your door is open, if you keep on walking, you may go outside the room after some time, right? Mathematically, what is happening and physically what is happening? If your door of your room is open, you will go outside after some time. Mathematically, what happens? There is a sequence which is inside. A person is inside the room, but if door is open, he can go outside. If door is open. Similarly, mathematically, interval is open means if there is a sequence which is inside the state interval, but its limit is outside, its destiny is outside. Right. So that you should understand what is the meaning of open. Is it clear?
Yes, sir.
Yes, sir.
Fine. So now if I look at interval 0 to 1 is a closed interval. What do you mean by closed interval? Have you heard this word? This is a closed interval. This is open interval. So why this interval is closed interval? Yes. So because there is no way to go out. There is no way to. So your room is closed. Door is closed. Means what? If you keep on moving in room in any way, you will never be outside the room. Do you understand this? That is the meaning of room is closed. Yes. What I am saying, my sentence is clear. When we say that our room is closed, yes, you keep on moving in the room. If your door is closed, you will never be outside the room. You cannot go outside the room. Yes. Now, mathematically, some set or some interval is closed means what? You can. There is no way to go out means.
You can't exceed the 0 and 1.
That means you take any steps, you will not go outside the room. Means you take any sequence in the set. Limit is not outside the set. Destiny is not outside. You cannot go outside. Do you understand? For any sequence xn in I, if xn converges, then limit of xn remains inside I. Do you understand this philosophy is same? Yes, just your room is closed or room is open. So interval is open, interval is closed. So mathematically, we are trying to understand this openness and closeness, which we already these things we already are there in our day-to-day life, right? Do you understand the meaning of openness, closeness?
Yes, sir.
Yes, sir.
Now, so if I take interval 0 to infinity, what can you say about it? Is it closed or open? Yes.
Sir, open at infinity.
What I said, what is my understanding of openness or closeness? Can I go outside? Suppose you keep on walking on this interval. Will you be outside this interval at any time? Suppose you keep on walking on right hand side in the right hand direction on this interval. Will you be outside the interval after some time? Right.
Sir.
So, philosophically, suppose you have a room and you enter in the room. Now door is closed and another end is open, but which is at infinity. Can you go outside the room? Length of your room is infinite, and you enter and see this here you enter the room. Here it is a door. You enter and now door is closed. And now here is another end which is open, but it is at infinity. Can you go outside the room? Length of room is infinite. Can you go outside the room?
No, sir.
No. That's why I'm saying that so physically or in real life, you can relate these things similarly. So is it closed? Is this interval closed?
Yes, sir.
Yes.
Yes.
That means you cannot find a sequence which is inside this and limit is outside. That is not possible. It is closed. So I is equal to 0 to infinity. Is it closed? Now I have kept the room of uh, door of room also open, and length of room is infinite, so it is open. Correct? Why? Because I can have a sequence 1 by n which is in I, but limit of xn is not in I, so it is open. Destiny is not inside the room. So this is possible in this case, right? So, so this interval 0 to infinity is closed. Second interval is open. Now, the question I would like to ask: what is the difference? The difference between what is the difference between I1 is equal to 0 to 1 and I2 is equal to 0 to infinity, and what are the similarity? What is the similarity between these two intervals?
Both are closed.
Yes, I1 and I2 are both closed. Okay, now what is the difference? This is a crucial thing that we are going to use in the further discussion. What is the difference now? Yes,
So the door of I2 is at infinite length.
means what? Means what? Mathematically, physically, you can say it is at infinity. We cannot reach that end, but that is a physical or real life situation. Mathematically, now, how will you write it down?
The first interval is finite and the second is infinite.
Means what? I1 is bounded and I2 is unbounded. Do you understand bounded set and unbounded set? That means I1 has a lower bound as well as upper bound, but I2 does not have upper bound. Is it clear?
Yes, sir.
Yes.
Yes.
Thus, I1 is a closed and bounded, whereas I2 is closed but not bounded. Closed but not bounded. So if these ideas are clear, then we are now in the position to state the next theorem, so which is very essential theorem in analysis and calculus, which is also called as a difficult theorem because its proof is little bit difficult, even though it is very important theorem. So boundedness theorem. So difficult theorem 1, you can say, right? Suppose let I be a closed and so be a closed and bounded interval. if f from I to R is a continuous function, then f is bounded on I. Okay, so now read the statement carefully, and do you know the meaning of each and every word in this statement? Do you know the meaning of closed and bounded? Do you know meaning of interval? Do you know meaning of continuous function? Do you know meaning of bounded function? Yes.
Yes, sir.
Now the idea is clear. Statement is clear.
Yes, sir.
Right. So that is a continuous function on a closed and bounded interval is bounded. Right? A continuous function on closed and bounded interval is bounded. Right. So that is there exists m. Okay, that function is bounded means what? There exists a number m such that absolute value of fx is less than or equal to m for every x in interval I. So once statement is clear, we can see discuss the proof. There are different ways to prove this, right? By direct assertion or by contradiction or by sequential criteria. There are different ways to prove this. Right, we'll use sequential criteria because at this moment it is easy to apply, right? Okay, so what is given? First of all, list the given conditions. I is equal to AB is closed and bounded. Right, only closed is not sufficient. Do you understand? When only closed, where you even set is closed, it may not be bounded. That we already discussed. So I is a closed and bounded interval. Second point is f from I to R is continuous. Right? What is our claim? What we wish to prove? F is bounded on this interval I. That is what we wish to prove. There exists some number m such that absolute value of fx is less than or equal to m for every x in I. Okay, so far everything is clear. Yes.
Yes, sir.
Fine. So, okay, so how to prove that there is some m? Right now, remember that what is our target? What is our final aim? What is our ultimate aim? Ultimately, there is some aim that we want to prove. Suppose. So, on the contrary, suppose, suppose there is no such aim. Right? Suppose there is no, we are assuming the negation, then we'll get some contradiction. Do you understand logically what I want to do now? Yes? Do you understand my strategy?
Yes.
My strategy is that I will assume that suppose f is not bounded, then I will get something contradictory. See, before going to this, let me tell you uh, what is given P and Q implies R. This is our aim. what is my implies P and Q implies R is equivalent to P and Q implies R is equivalent to what? What is the negation? Negation of R implies negation of P and Q. But what is the negation of P and Q? Is negation of P or negation of Q? Do you agree?
Yes, sir.
Fine. So here, what is our statement P? Domain of F is I, closed and bounded interval. And what is my statement Q? F is continuous on I. What is my statement R here? What is my statement R?
F is
Yes,
bounded on I.
F is bounded on I. Right. So F is bounded on I. Now, what is my strategy? I am assuming negation of R, and then I will get negation of P or negation of Q. This is a strategy. Logically, once it is clear, then the rest of the job is very easy, right? Okay, suppose I am saying that there is no such M, so function is not bounded. So since F is not bounded on I, M is equal to 1 is not a bound for F. Is it correct? Do we agree? Yes, we agree.
Yes, sir.
So M is equal to 1 is not a bound for F on I. So that means the condition of boundedness fails for M is equal to 1. That means there exists some X in I such that absolute value of F of X is greater than M is equal to 1. Do we agree?
Yes.
That means there is specific X. I will call it as X1, right? Because I want to look at a X specific X1 for which F of X1 is greater than 1. Similarly, M is equal to 2 is not a bound for F. So there exists X2 in the domain I such that F of X2 is greater than 2. Do you agree? Do you agree with my statement?
Yes,
Yes,
sir.
sir.
Now I will extend this idea. Uh, is M is equal to 3 upper bound? Is M is equal to 3 bound?
No, sir.
No. M is equal to 4 is not bound. M is equal to 5 is not bound. M is equal to 100 is not bound. So whatever M is equal to, suppose I take 3, I can produce X3, right? So in general, M is equal to N. Whatever N you select is not a bound for F on I, so that there exists M is equal to N is not bound, so there exists Xn in I such that the absolute value of Fxn is greater than N, right? And so this is true for each N. So for M is equal to 1, I have produced X1, right? So thus for M is equal to 1, I produce X1. For 2, I produce x2. For 3, I produce x3, and so on, such that f of xn is greater than n for all n, right? So f of x1 is greater than 1, f of x2 greater than 2, f of x3 greater than. In this way, I produce a sequence, right? So up to this, everything is clear.
Yes, sir.
So thus, we produce a sequence xn in I such that we produce a sequence xn in I such that f of xn is greater than n for all n. So note that xn belongs to I for all n. That means what? Xn is in I means xn is in A to B for all n. Means what? A less equal xn less equal B for all n. Right? Therefore, can I say that xn is bounded? Yes. Can I say that xn is a bounded
Yes, sir.
sequence
Yes, sir.
in I? And therefore, by Bolzano-Weierstrass theorem, now the role of Bolzano-Weierstrass, what we can say? By Bolzano-Weierstrass
There
theorem,
is a
what can?
conversion.
So there exists a convergent subsequence xn k of xn, right? So let now limit k tends to infinity. So xn k is a convergent, so its limit is x, right? Its limit is x. So observe that xn k, so xn k is the sequence in I.
Yes, sir.
Yes, sir.
Yes.
Therefore, what can you say about limit of this sequence? Is it in I?
Yes, sir.
So why?
Closed interval.
Because
I is a closed interval.
yes, I is a closed interval. Now, where we use the property of closeness, here we need the property of closeness. Where we use the property of boundedness of I, where we need it, since it is mentioned in the statement, that means we must use the property of boundedness of I. And where we use, right, something is used in the statement or some hypothesis is given, that means we should use it somewhere in the proof. And where we need it, boundedness of I. Yes,
To
in
show
the
xn is
statement.
bounded.
Yes, because I is a bounded interval, sequence xn is bounded, and therefore we can apply Bolzano-Weierstrass theorem. And once we apply Bolzano-Weierstrass theorem, xnk converges in I. Why? Because I is closed. Therefore, we use both of the conditions. I is closed and bounded. That's why it is mentioned in the theorem. Therefore, x is in I. Right. Now, therefore, can I say that f is continuous at x? Yes. Can I say that f is continuous at x? Yes. By sequence. Is it true? F is continuous at x? Why? What is given hypothesis? What is given hypothesis? Function is continuous on I and x is member of I. So can I say f is continuous at x?
Yes, sir.
Yes. So x is a member of I that we see, and f is continuous everywhere on I, so f is continuous at x by sequential criteria. What is limit k tends to infinity f of x n k? So x n k converges to x. Therefore, what can you say about f of x n k? Where it should converge? Yes,
F of x.
f of x, right? So f of x n k converges to f of x by sequential criteria. Now, so and so f of x n, therefore the sequence f of x n k is convergent and converges to what? The number fx. Do we agree?
Yes, sir.
But and therefore f of x n k is bounded sequence.
Yes, sir.
Because every convergent sequence is bounded. But so we came to conclusion that fxn is bounded, but by our construction f of xn k is greater than, what is our construction of the sequence? F of xn is greater than n for all n, and f of xn k are some of them. So what can you say about f of xn k? What can you say about f of xn k? Is it greater
It
than
must be
nk?
unbounded.
Nk is greater than k for all k. And if it is true for all k as k tends to infinity, how it will be remain bounded? Then f x n k is unbounded. Contradiction. Right? So why we get contradiction? Immediately in previous step we got the f x n k is bounded, and immediately in second step we get that it is unbounded. So which is a contradiction, and hence our assumption is wrong. Hence is wrong. Therefore, what we can conclude, f is bounded. What was our assumption? The function is not bounded, and due to that assumption, we reach to the contradictory thing, or that leads us to contradiction. So we say that f is bounded. Is it clear?
Yes, sir.
Yes, sir.
Okay. So you go through the proof once again. Next time we'll see. If you have any doubt, we'll you read it again. If you have any doubt, we will discuss next time, and we'll see some more extensions of this. So if you have any doubt, you can ask. Otherwise, we'll stop here.